let's look at the first kind of sentence that you're going to be encountering if you were to solve these questions. Okay, so the first kind of statement that you can encounter in these questions is the all statement. How is it going to look like? It's going to look like this. Okay, now why have I written X and Y? I've written X and Y because these can be just names. Okay, you can, instead of X, you can write women, you can write anything, pens, any noun, newspapers, diaries, men, cities, countries, maybe people. They can say all Harsh or Rahul, right? It's going to be very weird, sound very weird, but then you have to just remember that it's just a name. It's like all X or Y, right? Now when we try and represent all X or Y, when I say represent, how do you think, what do you think I'm saying? So when I say all X or Y, we're talking about sets, okay? Now think about it this way. If I were to represent a set called X and say all of X is Y, right? How can we represent it? There's a possibility that X was basically a subset of Y. Therefore, we said all X are Y, right? Now this is one possible representation of all X are Y, right? Now remember when we were teaching, remember when we were studying the structure of an argument in deductive logic, and I told you there is absolutely no scope for an assumption. Remember that? How can we assume that this would be the only possible representation of all X or Y? We can't, right? What I'm trying to tell you is that we can't leave any scope for any possibility running out for the representation of a sentence, right? So while all X or Y can be represented in this manner where X is a subset of Y, there's an equal chance and equal possibility that we said all X or Y because both these sets were absolutely the same set, and therefore we went ahead and said all X or Y, right? So what are we doing over here? We have a random statement with us. We're trying to draw all possible representations of that statement by aid of Venn diagrams, right? So when I said there is absolutely no scope for assumption, the only thing that I'm trying to tell you is that we can't assume that the statement will only look like a certain representation. We have to take care of all the possibilities. Okay, perfect. So these are the two ways that we can represent all X or Y, right? Now remember the structure of the argument. There was a premise, there was an assumption, and there's a conclusion, right? Assumption is drawn out, assumption is kicked out of the window. What is the next thing that we're brought to? Well, we're looking at the conclusion. What are we supposed to do over here? We're supposed to draw a conclusion from these two representations of all X or Y. What can it be? Can we say all Y are X? Can we say on the basis of all X or Y, on the basis of the possible representations that we have looked at for all X or Y, can we say all Y are X? Let's look at the second representation here. Can we say all Y are X? Yes, we can. Why? Because they're basically two superimposed sets. They are equal in size, shape, constitution, everything. So X and Y are basically the same set. Therefore, we can say all Y are X if we look at the second representation only. But if we were to look at the first representation, can we say all Y are X? What about these Y's? Can we say all Y are X? No, we can't. Therefore, the possible solution for all X or Y cannot be all Y are X. Okay? Let's look at Are some y's x? Well, yeah, the ones that are inside x in the first statement, in the first representation, those x's, those y's that are inside x, those some y's are x, some y are x. Possible in this case. Let's look at the second representation. Second representation where we're saying x is equal to y. If all of y are x, then some of the y are anyway x, right? Try and understand it this way. If all the y's are x, it is anyway true for some, right? If all y's are x, some will anyway be x, right? Therefore, some y's are x is the conclusion for the statement all x are y. Did you understand what I did over there? Right? So you'd have a little problem processing if all x are y, if all y are x, then how some? Look at it this way. If all the y's, everything that was y was x, some y are anyway x, right? So we've got to see that the possible conclusion, is it true for both of our representations or not? The logic is going to be different, of course, but is it true or not? Yes, it is true. Therefore, the conclusion some y are x is going to hold true for the statement all x are y. I hope you could understand that. Let's look at the second statement that we are going to encounter. The second statement is the sum statement. Sum x are y, right? We still have to remember that x and y are nothing but sets. They are just names of things. X can be anything, men, women, plant, children, pen, pencils, whatever, and so can be y, right? Now we're going to look for means to represent this statement, okay? So what comes to your mind whenever you think of sum? Sets? What sort of sets? Intersecting sets? Yeah. This is the first possible representation that you can draw for some x or y, right? Which is the area that we're talking about. We're talking about this area, right? Where some x's are y, right? Of course, first possible representation of some x or y. Can we draw this? Those x's that are inside this area, those x's are y. Makes sense, right? Can be drawn. Now remember when we did the all statement? What if all the x's were y? If all the x's were y, then anyway some x's are y, right? If all the x's are y, we can say it is true for some as well, right? Possible way of drawing the statement again, right? I hope you could get that back. Now, again the same logic. If all the x's were y, can possibly even be drawn like this. The fourth possible representation of the statement, right? Did you understand what we did over here? Look at the first representation. Easy, right? Some x or y, you draw two intersecting sets. The place where they intersect are those places where some x's are y. When we drew the second representation, we're saying that, of course, those x's inside the y region, because y is a subset of x, become those some x's that are y, right? But then look at the third and the fourth. If all the x's are y, in case that x is a subset, or if both the sets are equal, can you say some x are y? Of course we can. Why? Because if all the x's are y, then definitely some x's are y, right? Understood that point? Slightly heavy over here. If you could understand that, great. Otherwise you can look at my first the first thing again, the first all statement again. Maybe you'd get that again, right? Perfect. Let's look at the conclusion part of it now. If you were to look at the conclusion, what would you say? Can you say all y are x? Can you say? Now, for a conclusion to be true for a certain statement, it has to be true for all the representations. Can we say all x are y? Can it be a possible solution? It cannot be. Why? Because it's not true for the first statement, right? Not all x's are y. They're just intersecting. Can you say it is true for the second one? Of course not, because there are some x's which are outside y. So therefore, all x's are not y. However, for the third and the fourth, it is true. But then for a conclusion to be valid, it has to be true for all the representations, right? Therefore, all x are y is not a possible conclusion. Similarly, all y are x can also be not a possible solution for this statement. Let's look at some y are x. Can we say that the conclusion for this statement can be some y are x? Let's look at the first representation. Definitely. Those that lie in the shaded area are those some y's that are x's. Perfect. In the second representation, if all the y's are x, then definitely some y's are x. Awesome. It is possible there. And look at the third statement. Those y's that are inside x here, inside the shaded region, those y's are x. Therefore, some y's are x. Awesome. Possible. And if all the y's are x, like the fourth statement, anyway, some y's are x, right? So we see for some x are y, the possible solution is some y are x, right? Awesome. Great, great. I hope you could understand that part.